All right, afternoon, everyone. We got 3 more weeks to go. I know everyone's probably getting excited and ready to get this class over with. Many of you have put in a lot of effort, and it's definitely showing. So to continue on, I want to do a couple problems in the homework to show how we use technology to solve these problems, especially this week. So we've kind of transitioned into linear regression, or least squares, as it's sometimes called. And basically, the concept of this week is if we take some data and we have a x and a y, and typically x is our explanatory variable and y is our response variable, and we can plot those and try to fit a line to them. And we want to see if they have a linear relationship. So if you remember back in algebra, if you've taken it, y equals mx plus b. So this looks very similar to that, where the value in front of the x is our slope. And in this case, we will use that as showing if there is a correlation or a relationship to our variables. So the key to this is making sure you pick the right explanatory variable and the right response. If you get them backwards, then you still get a linear relationship. It's just inverse of what you're looking for. The formulas for this week can look very challenging, but they're not. They're just very tedious, and there's a lot of computing of x and y's. So I really want you to try to use the technology, because as you'll see here, we got to really look into if these models are good or not, and we have to look at why they could be and why they can't be to figure out how to answer the question. So the calculations are important, but we really got to understand what the calculations mean, because just because we get an answer doesn't mean it's a good answer, and we got to go through it. So that's why I use technology to do the calculations, but understand what do the calculations and analysis mean. So we'll basically do the exact same thing for this week and next week. So nothing's going to change in how we compute it. It's just how we interpret the stuff. So if you understand this week, next week we'll go a little more in detail, but as far as using technology, it's the same. So first, let's look at problem 4. So pediatrician wants to determine the relationship that may exist between a child's height and the head circumference. So we have some data of 8 children. This is their heights and then their head circumferences. We read part A. If the pediatrician wants to use height to predict head. So now this is how we know what we're doing. We're going to use height as our explanatory variable to make a prediction on our head circumference. So this would be our response variable. So the explanatory variable is height, and the response variable is head, and that's how it always will be. Kind of think, what data are we using to make a prediction on the other variable, and that other variable is going to respond to the other data. That's why it's called an explanatory and a response variable. Now, we want to draw a scatter plot to give us a visual. So the best way to do that is, hopefully we've been doing this now, you click on the little box next to your data, and you can either open in StatCrunch or Excel. I'm going to open in StatCrunch. I'm going to load here for a minute. And since we're going to build a graph, we click on Graph, and you come down and you see scatter plot, and that's what we want, a scatter plot. And we put in our x variable, which we said is our explanatory, our height, and our response variable is our y, and our head circumferences. A lot of different things you can do to make these graphs all pretty and stuff if you actually do this analysis for presentation. I want points. We don't want to connect them. Filled circle, point size, line size, dividers, all this stuff I'm just going to leave turned off. If you want to make it colorful or labels, you can type things in, but you have to type it in. But ours, because our data is labeled, we don't have to type it in. But if you wanted to change it, you can. If you want to put a title, all these things that you can make these graphs really nice and eye-pleasing. So we'll go click on Compute. See, we didn't have to type in labels because our data was labeled, so it already put it in for us. So you can see, we start down here at the low end, and as our height increases, our head circumference kind of slowly goes up. We do have some dips, and that's why these models are never perfect, and that's why we have to look and see how good they really are. So I'm going to move this over so we can kind of still see it. And then I'm going to bring over this so we can look at all the graphs. All right, perfect. All right. Key here to look at your labels. So height is our explanatory, so it's our bottom axis, or our horizontal, and head circumference is our vertical. So if we look at our answer keys, you can see we have circumference, circumference, height, and height. Well, just by looking at the labels, we can see A and B can't be the right answer because they're in the wrong spot. It has to be height. So it's either C or D. So we kind of look, our data kind of goes up, and then it has 3 dots right in a row. 3 dots right in a row. These 3 dots go up, these go horizontal. So therefore our answer is D. To get this graph, you would have had to swap your X and Y's. And if you would have done that because of the labels, you actually would have got graph B. So if your graph looked like this, then it means you got your explanatory and your response variables backwards. All right, so make sure you put them in the right order. That's always going to be key when we're doing this. Now, we need to calculate our R, our correlation coefficient. All right, and that is the formula I put in the announcement. It looks very ugly and cumbersome, but it's just comparing your X's and your Y's. And you're kind of looking, if we put a line fitted through this, we want to put the best line, we have the minimum error, and the highest correlation coefficient. And that's what those values do. It finds the differences between each one of these points, X and Y's, in the line. And that's why the formula looks rough, but it's really just comparing X versus Y. So shrink this down. So to do that, we're going to click on Stat this week, and next week we're doing Regression. This week we're doing Simple Linear. Next week we'll also do some Simple Linear, but we'll also do Multiple Linear. So when we go to Multiple Regression next week, all you're going to do is click on Multiple Linear Regression. For now, we're in Simple Linear. Our X variable was our height. Our Y variable is our head circumference. Hypothesis test. Yeah, we'll talk about a little bit this week, but we're really getting into this next week. Here, we want to know if the value in front of the X is 0 or not. In this case, we hope it's not, because if it's not, then that proves there is a relationship. And next week, we'll learn how to interpret all this. If we want to build a confidence interval, then you just click on that box, and you can build confidence intervals. Fitted line plot, I'll put that in here just so we can look at it. Residuals and all that stuff, we'll kind of get into that as well. But this is where you kind of select if you have a problem to ask you to build all these type of graphs. You just highlight them, and we'll highlight one. All right, fine. I want the fitted line over residuals. But if you need residuals, you just have to rewrite it again. Click on Compute. Pull this up. So if the blue arrow here is because I have it. So click over this. There's our same scatter plot, but there is the line that goes through it. And you can see the big difference between these, right? So some of these points are further away, some are kind of close. And that goes into our help calculating our correlation of coefficient. I took a screenshot of this. It's also put in the announcement and put some notes and highlighted things of what's key this week. So here, head circumference, inches, equals this line into height, where H is our X. Notice this line is also the same values as down here. Sometimes it's a little easier to use these values than these, because depending on how you want to write up your equation. But for this problem, we're looking for the correlational coefficient, which is R, which also says its name right here, equals 0.785. So that is the value that we put in here. So does a linear relationship exist between the height and the head circumference? To do that, you compare critical values. So I click on this R, and our sample size was 8, right? So we come down here to 8, and we see 0.707. Bring this back up and over so you can see both. And we compare that to our correlation of coefficient, which is 0.785. 0.785 is greater than 0.707. Therefore, this model is good for doing predictions. All right, so I can click done on that. So yes, we can use our model. So there appears to be a positive linear relationship because R is positive and it is greater than the critical value. Now, we'll go to one that does have us do a lot more steps. Question 10. Let me close up my StatCrunch here again. I'm going to use Excel a little bit on this one so I have it up. I want to use it as a calculator. Click over here and we look at our data. And as before, I'm going to click on the little boxes, open in StatCrunch. Close our data. So part A wants me to find the least squares regression line. So again, we'll go to Stat, Regression, Simple Linear, click on it. Now, we're going to read so we figure out what our X's are. Find the least squares regression line treating Coca-Cola consumption per week as the explanatory variable. That means Coca-Cola is X. Number of Cokes per week, X. Therefore, we're predicting bone density of Y. Scroll down here, fitted line plot. I always just like to have it to look at it, and then click compute. All right, least squares line. Be careful when you read. So here, bone density is our Y hat. It's our estimator, right? And up here, it puts the value without X first, and then X. But down here in the answer, it wants the X answer first. That's why I don't typically default to this, and I'd like to go down here. Because the slope is the value that's in front of X. So this is negative 0.003. Negative 0.003. Perfect. Plus the intercept. There's the intercept. So my answer is C. You can see some of these are close. So you gotta make sure you pick the right value. And that's where, like this one, D, could get you in trouble if you just put this because this number comes first. Like, oh, there it is. That's right there. And you put that. That's not the number in front of X. So make sure you read the output in what Pearson has very carefully. Now it wants us to kind of interpret what all these things mean. So the number, the slope, this is the number in front of X, the negative 0.003. Because it's negative, we say it decreases. The other option is increase. But in this case, it's going to be decrease because it's negative, and it's going to decrease by this amount. Right? Because basically it says every time we add one value. So if I put 1 in for a Coke, you get that. If I put 2, it doubles the slope. If I put 3, it triples the slope. So that's why it says it decreases, because it's negative, by this much by how many on average you drink. We come down to intercept. Intercept is the value that's not with the X, so with the 0.8865. The way you interpret intercept is you assume the X to be 0. So if X is 0, it cancels this out, because anything times 0 is 0. So Y will just equal 0.8865. So for a woman who does not drink Coke, so doesn't drink anything, so Coke is 0, we expect her bone mineral density to be 0.8865 on average, according to our model. So that's how those values, you interpret them. How do you make a prediction? This is where I like to have Excel over StatCrunch. So I'll scroll my StatCrunch down. Go another way. And like I said before, if you put an equal sign in an empty cell in Excel, it turns it into a calculator. So all I'm going to do is I'm going to come back up to my model, and I'm going to put in negative 0.003, and then I'm going to multiply that by whatever my X is. So I come down here, and it says I want to predict using 4 colas per week. So I put in a 4, and then I add my intercept. Back up here, 0.8865. 0.8865. And I get a value of 0.8745. Now, we have to make sure our model's good. How do we make sure our model's good? We look at the coalition of coefficient, right? So, bring our table back up. We have a sample of 15 women. So I come down here to 15. I bring back up my output. I look at my R, which is negative. Remember, we have to look at the absolute value of it being positive. So we're going to compare it to positive 0.816. Positive 0.816 is greater than 0.514. Therefore, my model is good to make predictions. If you have a problem where it's not, you can't use your model. So therefore, what you have to do is you have to bring open my data for a minute. Average, like we learned way back in week 1. All of our Y values, and then that would be your best predictor variable. So if your model's not good, just take the average of your Y data or your response variable, and that will be your predictor variable no matter what X is if your model is not good. Our model is good, so I can just use my model like we did in Excel, 0.8745, come down. All right, why does that say 0.8749? I must have typed the number in wrong. 0.003 times 4 plus 0.8865. I typed this in wrong. Negative 0.003. 2 zeros and a 3. I'll put an extra 0. Should I make a difference? Times 4 plus 0.8865. That is weird. As you see, I did this earlier and it works. I don't know why my Excel is not working this time. So let me delete it to start over to make sure I didn't do anything wrong. Negative 0.00, point in, 0.003 times 4 plus 0.8865. All right, I can't type it in to change the answer. If you do this and it gives you to be wrong, please take a screenshot and email it to me. I'm off a little bit. I don't know why it's doing that. So if that happens to you, just email me so I can override and make your answers correct. And some of you have done that for, because sometimes this Pearson does some weird things. All right, now it tells me I'm 0.87749, so we'll use it. We're going to compare what they have as an actual. So the researchers found a woman who consumed 4 colas per week to have a bone mineral density of 0.873. So if we do 0.873, that is bigger than this number. So what are we really comparing? Because it's kind of weird here, right? So is the woman's bone mineral density above or below average? Oh, is this woman's above or below average among all women who consume 4 colas per week? So below average. All right. Would you recommend using the model found in Part A to make a prediction? Here's where you have to be careful again. 2 cans of cola per day. Our model does what? Cans per week. So you got to multiply 2 times 7, which is 14. So we go back to our data, and we see 14 is greater than 8. So it's outside the scope of our original data. We never want our user models to predict outside of our original data. So since it's outside our data, we would say no. I would not want to use our model to predict someone that drinks 14 colas per week. So the answer is no. And I'm sorry, I have no idea why Excel's doing this. It usually gets the number on perfect. I did it early to make sure everything worked before I made this video, and now I redo it, and for some reason I get a different number. If that happens, just email me. There is some quirks sometimes with Pearson, but it should be close. So if it's not, please email me. Lot to do these in each question, so please use technology so we can get through this. If you are having issues, please email me. Hopefully these videos are helping on seeing how we can use StatCrunch. Excel also has it, so if you prefer Excel, just use your data analysis that we installed in week 1. There is a regression. You do the same thing, input X and Y, and your output looks very similar to what is in StatCrunch. All right, have a good week. Again, email me if you have any concerns. We're going to keep doing linear regression next week, so we'll use these same tools. We'll just look at it a different way. And then our final week, we have the exam, and we'll do a little bit of ANOVA. Talk to you and see you online. Have a good night.